Hello everyone. Today we'll start with Heisenberg uncertainty principle. So, according to D. Broglie, a microscopic particle like electrons has both wave and particle-like properties. Now, after this, Werner Heisenberg in 1927 pointed that we cannot measure simultaneously the exact position and velocity of a microscopic particle with absolute accuracy. And this is the Heisenberg uncertainty principle. We cannot measure exact position and exact velocity simultaneously of a microscopic particle. We cannot measure, right? So mathematically, this is equal to uncertainty in position, which is delta x, into uncertainty in momentum, is either greater than or equal to h upon 4 pi. Now, this is uncertainty in position, and this is momentum, change in momentum. Now, delta p, which is momentum, is equal to mass into change in velocity, because mass is constant for a microscopic particle like electron. Mass is constant. So, this is the mathematical expression of the Heisenberg uncertainty principle. We can define the principle with this statement also. So it is equal to the product of uncertainty in the position and uncertainty in the momentum, either greater than or equal to h upon 4 pi. Now h is Planck's constant as usual. Its value is 6.36 into 10 to the power 34 minus 34 kilogram meter square per second. Now, what is the significance of this uncertainty principle? So it means we cannot see microscopic particles without disturbing them. For example, if we have to observe an electron, so this is the path in which the electron is going on, and we use electron microscope to view it. This is microscope. In that case, observe it, you put light on it. So this is incident photon. So by gaining the energy of this light, this electron will change its path. The original, the intended path is this, but it changed to the new path. So we ultimately disturb its position. So it is not possible to measure its velocity as well as position simultaneously. So this is Heisenberg uncertainty principle. Now, what is its impact on our daily life? It has no impact on our daily life because we are not dealing with microscopic particles in our day-to-day life. However, it has significance in numericals or in calculations regarding numericals and in further studies. But in day-to-day life, it has no significance. Even for a ball of like 10 grams, this has no significance. Now, if the value of this delta x is small, it means the certainty in the principle is large. Uncertainty is minimum, small value. The certainty is large. So in that case, the delta p value will be large. And if this is small, then uncertainty in position is large. Right? Suppose if the uncertainty in the position is 0, then it becomes infinity. So we can find exact position, but the momentum or the velocity in that case, error in velocity is very large. In that case, error in velocity is very large. This relation can also be utilized to prove that electron is not present in nucleus. So we can put the value of Planck's constant. So in that case, the uncertainty in the position is equal to the diameter of the nucleus, which is 10 raised to power minus 15 meter. 10 raised to power minus 15 meter. Right? And the velocity uncertainty should be less than the speed of light. Velocity uncertainty should be less than the speed of light. And we can put the mass of electron 9.1 into 10 to the minus 31. And by doing the calculation, the velocity comes is around is greater than the speed of light. It means it cannot exist inside the nucleus with this uncertainty in the position. So hence this can also prove the location of the electron outside the nucleus. Okay. Now, next is the reason of failure of Bohr's model. So, reason of failure of Bohr's model is the concept of orbits. So, in Bohr's model, the exact position of the microscopic particle along with its energy, that is velocity, is there, is considered. But Bohr ignored the Heisenberg's uncertainty principle. It also ignores the dual nature of matter. So there are some other limitations like Zeeman effect, Stark's effect, which are not in syllabus now. So the main failure of the Bohr's model is both path of electron and speed cannot be traced. Path and speed cannot be traced simultaneously, right? So this is the failure of the Bohr's model. Now next is quantum mechanical model of atom. Now the main points of quantum mechanical model of atom is the energy of electrons in an atom is quantized. Quantized means have certain specific values, only certain specific values. So there are quantized energy level in an atom. So there must be levels so that the energy of electrons can be quantized. The energy of levels should also be quantized. Next is, so as per the uncertainty principle, both position, exact position and momentum cannot be determined simultaneously. So only probability is there. The reason, the space where the electron can be found is determined. So the concept of orbits now is changed to orbital, and that orbital cannot have more than 2 electrons. What is the concept of atomic orbital? Now, atomic orbital, first of all, the region in the space around the nucleus where the probability of finding the electron is maximum is known as atomic orbital. So it is the three-dimensional space around the nucleus where the probability of finding the electron is maximum. How it differs from the orbit? Orbits are the circular paths, well-defined circular paths in which the electron revolves. So these are the space, orbitals are the space around the nucleus where the probability of finding the electron is maximum. So 90 to 95% of chances that space have electrons. Now, here, orbit is one-dimensional, in a plane, motion in a plane. Here, in case of orbital, there's a three-dimensional movement of an electron. Now orbits are circular, ring like, and orbitals are of different shapes. We'll discuss later on. Orbits do not have directional characters. So they are circular, do not have directional characters. So in case of orbitals, except S, all have directional characters. Now, maximum number of electrons which can be accommodated in an orbit is 2n square, where n is the shell number, and in case of orbital, no more than 2 electrons can be in an orbital. Right. Now, next is quantum number. So here is the difference. I'll repeat once again. Orbit is a well-defined circular path according to Bohr in which electron revolves around the nucleus in a plane. And the maximum number of electrons which can accommodate in an orbit are 2n square, where n is the shell number. Whereas orbital is a space as a region around the nucleus where the probability of finding the electron is maximum, and it is the three-dimensional space. So it means it represents the three-dimensional motion of the electron. It can have different shapes, and an orbital cannot accommodate more than 2 electrons. Now, next topic is quantum numbers. We have in our syllabus the quantum model of atom, which is given by Erwin Schrödinger. So Schrödinger gave an equation which is not in our syllabus. We have only quantum numbers to discuss, and quantum number is a part of this mechanical model. Right now, the quantum numbers, it is a set of 4 numbers which give us complete address, which give us complete information about the electron. Which type of information? About its energy, its shape, its orientation, and its spin. So 4 main things: of its energy, shape, orientation, and its spin. And the first quantum number is principal quantum number. Now, which type of information we'll get from this quantum number is, the first is, it is the main energy level or the shell in which the electron in an atom is present. So it is same as given by the KLMN. So what we'll get from it, we'll get energy associated with an electron in that shell, and the distance from the nucleus. Right? So first shell is close to nucleus, the next is far from the nucleus, and next one is more further. It also determines the average distance of the electron from the nucleus. Now, starting from the nucleus, the shells are 1, 2, 3, 4, and denoted as K, L, M, N, and so on. The maximum number of electrons that a shell can have is 2n squared. Right, where n is the principal quantum number. Now, with the help of this number, we can also define the energy of hydrogen, electron, and like species, one electron species. And the formula is same as given by the Bohr. -2 pi square m e raised to power 4 z square by m square h square. H is Planck's constant, n is shell number, z is atomic number, e is the charge, m is the mass of the electron, pi is 3.14 and 2. So energy of the electron is negative inside the atom. So this is the main feature. The multi-electron atom is, it determines, in case of multi-electron atom, it determines only probable energy of electrons. Now the second quantum number, which is azimuthal quantum number or subsidiary, which is also known as angular quantum number. It is noted by small l. Now, inside the principal quantum number. Inside the principal quantum number, electrons do not have same energy. All electrons do not have same energy. Inside the principal quantum number, they have different energies. So based on this difference in energy, the shells are further divided into subshells or sub-levels. Energy levels into sub-levels or energy shells into subshells. Now, for a particular value of n, the value of subsidiary azimuthal quantum number can be 0 to n minus 1. For example, if n is 3, if n is equal to 3, then the value of L can be n 0, 1, 2. So L has three values for n is equal to 3. N is equal to 3, we have three subshells. The first one is 0, second is 1, and third is 2. We'll start from 0 and continue 1 less than the value of n. So we have three subshells for principal quantum number 3. Now, these are again designated as 0 is S, 1 is P, 2 is D, 3 is F, then G, then H, so on. Now the possible subshells of first four principal quantum numbers. The first principal quantum number 1, main shell 1. Now 1 L have only 0 value, 1 value. So 1 have only 1 value. So name of subshell becomes 1s because 1 is the principal shell and S is the subshell. So subshell is 1s and number of subshells 1. And in case of principal quantum number 2, we have two values of subshells, that is S and P, 0 and 1. 1 is less than 2, so 0 and 1. So it becomes 2s and 2p. 2s and 2p because 2 is the principal and S is the subshell. Then again 2 is the principal and P is the subshell. The total number of subshells 2. And in case of principal quantum number 3, we have three values of L, 0, 1, 2, and again 3s, then 3p, then 3d. And in case of 4, like 0, 1, 2, 3, 4s, 4p, 4d, and 4f. Now, subshells further differ in their energies, and the energy is of this order. S has the lower energy, then P, then D, then F. As we moving away from the nucleus, the value of the energy increases. Now the subsidiary azimuthal quantum number also gives orbital angular momentum L of the electron, which is related to its motion, circular motion, and also shapes of the orbitals present in the particular subshell. The angular momentum of electron is given as L into L plus 1 under root into H by 2 pi. H is Planck's constant, L is azimuthal quantum number. Right. So it gives angular momentum of the electron also present in any subshell. One more point, one maximum number of orbitals in a subshell is given by 2L plus 1. So azimuthal number into 2 plus 1. Like if value of L is equal to 1. If value of L is equal to 1. So it means it has three subshells, 2 into 1 plus 1. So here is given the value of L is 1. Has three orbitals in it. We'll discuss in magnetic quantum number this feature. And maximum number of electrons in a subshell is 4L plus 2. 4L plus 2. So this we will discuss here. Right. Now magnetic quantum number. Next quantum number is magnetic quantum number. So due to its angular motion, due to the angular motion of an electron, the nucleus produces an electric field. uh, which intends which turn lead to a magnetic field. The magnetic field of electron is likely to interact with the magnetic field of Earth. As a the result, the electron in a particular subshell acquires certain specific orientation, and these orientations are known as orbitals. Right? So, due to angular motion of electron around the nucleus, due to angular motion of electron, as it is charged particle, nucleus is also charged particle. The angular motion of a charged particle, opposite charged particle, around another charged particle leads to the production of an electric field which turns into magnetic field, and that magnetic field produced by the electron is interact with the magnetic field of Earth and results into the certain specific orientation which are known as orbitals, and these orbitals or orientations are determined with the help of magnetic quantum number. Now, the orientations are specified by the quantum number, magnetic quantum number, and how we'll get the orientation, value of orientations, and it depends on subsidiary azimuthal quantum number. For any value of L, the M can have minus L to 0, then to plus L value, minus L to 0, then to plus L value. And the number of values will give us the number of orientations or number of orbitals associated with that azimuthal quantum number. So like here we discussed L is equal to 1, the value of orbitals is 3. Now, if value of L is 1, then M has values minus 1, 0, plus 1. So it has 3 values. 3 values means 3 orientations. So minus to 0 to plus, minus 1 to 0 to plus 1. So 2L plus 1 or minus L 0 to plus L. So another example, if value of L is 2, subshell is B, the values will be, ML values will be, magnetic quantum number values will be minus 2, minus 1, 0, 1 and 2. So total are 5 values. So it means the D subshell has 5 orbitals in it. Right? Now, there are some orbitals in different subshells. So the value of L, if 0, then the subshell is S subshell, 0 is S subshell. The values of ML minus L to 0 to plus L, so value is 0, so again only 0, only 1 orbital is there, only because this is 1 value. Then in case of 1 is P subshell, and the value of ML, that is magnetic quantum number, is minus L to 0 to plus L, so 3 values, minus 1, 0 and plus 1. So 3 orbitals in P subshell. Like in case of D subshell, L is equal to 2, minus 2, minus 1, 0, plus 1, plus 2 are the values, and these are the 5 values. So 5 are the orbitals, total orbitals are 5. And the last quantum number is spin quantum number. An electron, besides charge and mass, also spin around its own axis, right? And due to which another quantum number, which is spin quantum number, is there. So it can rotate clockwise or anti-clockwise. So due to its 2 motions, it can have 2 values, either plus 1 upspin clockwise, minus 1 anti-clockwise downspin. Right? So an electron in an orbital can have only 1 value out of these 2. It cannot have both together. And right. The spin quantum number relates to the spin angular momentum, like azimuthal quantum number relates to angular momentum, and same on same basis it leads to angular momentum, spin angular momentum, which is s into s plus 1 under root h by 2 pi. So this is all for today. So next we'll do some questions based on quantum numbers, and then Pauli's exclusion principle and Hopper principle in the next class. Thank you.